Okay, here we are with the inclined plane. And this one, you'll notice, is in your formula chart at the back of your book. And this is the same that we've been seeing, but the tricky part is where's the DE and the DR? Well, it's not really tricky. It's just once you figure it out, then you can kind of see it. So if I've got some kind of cart that I need to push up this incline, what's the distance that I have to put an effort on the cart? Well, the effort is going to be this distance here. This distance here is my distance effort. It's how far I have to push the cart going up. My distance resistance is how I actually have to move it up vertical. Think if I'm going to put this onto, say, a truck over here that's this high, or a platform that's this high, the real effort that I'm getting, the real results that I'm getting out of it, is it's being moved up this high. So I had to go a farther distance to get it up this ramp, but really I just wanted to get it this high off the ground, and I didn't want to have to just lift it this high. So if we look at it with respect to the inclined plane, this is what we think about as L, the length of the plane. It's the horizontal, it's the diagonal distance going up. If you think in terms of a Pythagorean theorem, this would be the hypotenuse of this triangle right here. Here's my triangle. L is the hypotenuse of the triangle. And H is the vertical distance. My dr on an inclined plane is always going to be my vertical distance here for my dr. So the way they wrote it in your formula is this is L, it's the slope part, the slanted part here, and then H is the height going up and down. So it's still dE over dr. They just use different letters on your formula chart to kind of give you a hint on which numbers you're looking for there. So our first problem in our notes is this one right here. Same picture. What is the IMA? Well, here's my two numbers there. IMA, you can think of dE over dr, which is how I think of it. Or you can use L over H like they're suggesting in your book. But either way, this is my dE here, which is 15. And this is my dr here, which is the 5. Giving us a IMA of 3. Now AMA, very nice, it never ever changes. It's always FR over FE. Notice here my load is whatever's in the bucket that I need to be pushing up the ramp. And then my effort is I'm pushing it up the ramp. So this is my FR, and this is my FE. So FR is 60 pounds, FE is 20 pounds, giving us an AMA of 3. Okay, here's our example problem, and you'll notice this is a real engineering problem that a real engineer would deal with. Here we need a wheelchair accessible ramp because we've got stairs that are 2 foot tall. So we've got a building, it's got a couple of steps in the front of it, but we have to meet ADA code, that's American Disability Act code, that tells us how long of a ramp we need for someone with a wheelchair to get up the ramp. So the first thing I'm going to do is I'm going to draw a picture. And I'm going to label what I know. I know this end here is 2 foot. And I need to first find out what the minimum length of the ramp base is. So it's asking me how long this side needs to be. Well, you'll notice here it says the slope must be 1 to 12 or less, and the slope is equal to the rise over the run. Well, 1 to 12 is like this, 1 to 12, there's my slope I need. What's the rise of the ramp? Well, it's 2. And then the run is this part here, and that's conveniently what I'm looking for. You may be able to do this in your head, or you can use cross-multiplying, and we find that the length of the run, the length of the ramp base, needs to be 24 foot. This side needs to be 24 foot. Now it says, what's the length of the ramp? That's this side here, the length. We're going to use good old Pythagorean theorem to find that side.